All right, so this is the review for quiz 1, which is over cubic and cube root functions. The point of these videos is so that you can go at your own pace. You can pause, start over if you get stuck anywhere, and watch it as many times as you want. So let's begin. This was the quiz. So let's start with the first one. This one says, what do the cubic and cube root parent functions have in common? So what this is asking, and let's look at the answer choices. Domain, range, x-intercept, y-intercept. So what this is asking here is, we're going to compare the cubic and cube root parent functions. So we know that the cubic parent function is just the basic parent function for all cubics. This is going to be y is equal to x to the third power, right? The cube root parent function is going to be, actually let me use a different color. The cube root parent function is going to be the basic function, or the starting point, the most basic one for all cube root parent functions, for all cube root functions. So this is going to be y is equal to the third root of cube root of x, okay? So we should know how to graph these. This is going to be like this. This is your x and y axis, right? This is going to look something like that, right? In this one, the cube root parent function is going to look something like this. Okay, let me do that again. It's going to go through there. It's better. All right, so these are the shapes of the cube parent function and the cube root parent function. In case you don't know, or you forgot that, then you can always double check in your calculator. So let me clear that. You can go to y equals, and we're going to put x raised to the third power, and if we graph it, there it is, right? Let's go back and let's graph cube root parent function. Cube root, another way of writing it is just x to the 1/3 power, right? So we're going to do x raised to the 1/3 power. And that's how you graph that one. Okay, so, we have the calculator. We can always double check our work. So that is what we had. These are the two functions, the cube parent function, the cube root parent function. So what we're going to see is what they have in common in respect to domain, range, and x-intercept and y-intercept. So we're going to have to identify these elements for each one of these parent functions. So let's start with the domain. Okay, so the domain, what is the definition of domain? The domain is all the x's that are present in my function. Okay, let me use a different color. So in other words, I'm going to look at this function and I'm going to see what x's are part of it, what x's are present. So another way of looking at it is we're going to look at it from left to right, and we're going to see what x's belong here. So if we look at the function, what x's does it cover? So you see that this arrow says it keeps going forever. This is going to go that way forever, right? I'm exaggerating, of course. And this is going to go that way forever. So this says that for every x I pick going that way is going to be present in this function. Every x that I pick going that way is going to be present. So the domain for this, for the cube parent function, is going to be all reals, right? Because it includes every single x. Every x is part of this function. We do the same thing here. So again, we're going to look at it from left to right. And so we're asking what x's belong to this function, or part of this function. So this one is obvious, right? This is going to go that way forever and this way forever. So it doesn't matter what x I choose, it's going to be present. So this function is going to include what? Every x, or all real numbers. Okay. Now let's look at, okay, so what does that mean? They have the same domain. So this is true. Again, we're looking for all the ones that are in common. There could be more than one. Now let's look at the range. The range is what? The definition of the range is all the y's that are present in this function. So in other words, we're going to look at it like this, and we're going to ask ourselves, what y's belong or are present in this function? So as you can tell, if you look at it, this one is pretty obvious, right? It's going to go up forever, it's going to go down forever. So every single y is part of it. And how do we write that down? The range is going to be all real numbers. Okay. What about the range for this one? Again, I'm going to look at it going up and down because it's the y's. So this one is going to go up that way forever, right? I'm kind of exaggerating a little bit. And this one is also going to go that way. So again, it doesn't matter what y I pick is going to be present in this function. So that means the range is going to be all real numbers. So these two are also, they have that in common. What about the x-intercept and the y-intercept? Well, the x-intercept, so this is the x-axis, this is the y-axis, right? X-axis, y-axis. The function is going to cross it here at the origin, 0, 0. What about this one? It's going to cross, so again, I'm looking at the x-intercept. So I'm looking at this line and see when this line crosses that line. It's going to cross here. This is 0, 0. And they share that in common. What about the y-intercept? The y-intercept, we're looking at this axis. It crosses it at 0, 0. The y-intercept here, it crosses at 0, 0, 0, 0. So again, they have that one in common. So they have all these things that they have in common. So the answer here is going to be D. Let's go on to the next one. Number 2, it says, what is the domain of this? So what this is asking you is, this is a transformation of the parent function, right? So our parent function is y is equal to, as you can tell, x to the third. And we should be able to do this without a calculator. Y is equal to 1/2 x to the third plus 2. So if we remember, this plus 2 is going to move everything up by 2. This 1/2 is going to do a vertical compression, right? So when we graph this, this is going to look something like, let's see, this is going to, so if this is the parent function right here, this is going to squish it vertically and this is going to move it up. So this is going to look something like this. So instead of going through 0, 0, it's going to go through 1, 2 right here. It's going to look something like that. And I'm exaggerating a little bit just so you can tell that it got squashed down and it went up. It's asking for the domain. So it's looking for, what is the domain again? The domain is all the x's, all the x values. So again, I'm looking at it like this. And if we remember from the parent function, nothing has changed. This function covers all the x's because it keeps going that way and it's going to go that way forever. So the domain is all real numbers. It's A right here. Okay, let's keep going. Number 3. Number 3, it says, which equation matches the graph? So we have a graph and we have these 4 choices. One of these matches this one. So again, we're going to use the fact that we know what the parent function is. This one looks like what? An x to the third power or the third root of x. This is x cubed. So our problem is going to start here at, we can tell that the parent function is going to be y is equal to x to the third power. X to the third power actually goes through 0, 0, and it looks something like this. Okay, and so what is the difference between this one and that one? Okay, we can tell that this is the middle, right? And we know that this point moved over here. So we're going to use the transformation notation. Y is equal to a x minus h to the third plus k. A does something, right? H does something, k does something. So right here, a, you could tell that all these a's are either going to be 1 or -1. So we're not going to worry about that one yet. Well, actually, right here, did you notice that this is upside down? So the a is actually a negative, right? So you can already tell it's not going to be a and it's not going to be d. What else happened to the point in the middle, which is called the point of inflection? The point of inflection, where did it go? It moved from here to here. Okay, so if you can tell, it went 1, 2, 3 to the right, and it went 2 up. And what does h correspond to and what does k correspond to? We know that h moves left and right, what is opposite to intuition. And this one, the k moves up and down. So let's put all the clues together. up and down. Let's put all the clues together. And so we know that A, since they're all either 1 or -1, we know that it is a -1 because it flipped over. This is the one that goes sideways. It will move to the right 3. So we know that this is going to be x minus 3 to the third power. If it's a plus 3, it actually moves to the left. What about the k? The k, it went up by 2. So this is what? Plus 2. Y is equal to negative x, quantity x minus 3 to the third power, plus 2. The answer is B. Okay. So again, it's good to double check our work. So if for some reason we get stuck or we're not sure, we can check the answers on the calculator. So we can do that. Let's go to calculator, go to y equals. And we know that is B, so let's pretend we're going one by one and check which one it is. So we go to y equals. It's going to be negative x minus 3. X minus 3 raised to the third power plus 2. And there it is. This function is that one. If you're not sure, you can go to the table. What is this? 1, 2, 3. 3, 2 should be there. There it is. And then 4, 1 is right there. 2, 4. I'm sorry, 2, 3 is right here. So this is it. Okay, we could have done it one by one, and we could have also gotten the answer that way. Let's go on to the next one. What transformations on the graph of f of x equal to third root of x result in a graph of g of x equal to negative third root of x plus 5? So again, another transformation question. We're looking at what's the difference. If we start off with this one, which is what? This is the parent function for the cube roots. And I changed this to that. So I went from here, from f to g, right? So what is the difference? How does the graph change? So if we remember the notation, it's going to be very similar to the other one. So this negative in the front is going to do what? It's going to flip it. But we have to be more technical than that. So this x to the third is going to start off right here. This negative is actually going to flip it this way, right? And how do we say that? It flipped over what axis? It reflected. Another way of saying flip is it reflected over the x-axis. So the negative, so it reflects across x-axis. What else does it do? The plus 5. The plus 5 is inside the radicand. So it's affecting the x. So if we remember our transformation notation, this is going to move it up and down. If the plus 5 was out here, this would move it up and down. So this plus 5 moves it up, negative 5 moves it down. This plus 5 inside the radicand, the little house right here, is affecting the x. So it's going to move it sideways. Remember that our x, when you affect x, it does the opposite of the sign. So instead of moving right, because you know that the numbers go get bigger to the right, it's actually to the left. So this is going to go left by 5. So let's read the options. Those are my two transformations. So reflect across the x-axis and translate left. This one looks like it's the right answer. Reflect across the y-axis. This is definitely wrong. And translate up. This is also wrong. Stretch vertically. Vertically, this would have to change the number. So if it was like a 3 out here, a 3 out of here, then this would actually get stretched out. Stretched out as in it becomes taller like that. Does that make sense? So our answer here is 4. Okay, good. Let's keep going. We're almost done. This one says solve the cube root equation. So here we have an equation. We have the equal sign. That's what equation means. And we don't know what x is. We have to use arithmetic. We have to use algebra to figure out what x is. Another way of saying that is we want to get x by itself. We want x is equal to something. So how are we going to get there? Okay, so first of all, so we have this third root and we have this 6. So we have -4 over here. We're going to work from the outside in. we have to get rid of the third root here. So we have to do the opposite, right? We have